Hello students and welcome to this calculus lesson. In this video, we're going to finish up our lesson on continuity. In our previous video, we were learning about how continuity does not imply differentiability, but differentiability implies continuity. Today, we're going to start to hammer that home and actually use it in some practice problems. So let's get started. So the first thing that we're going to want to take a look at is that in order for a function to be differentiable at a value of x, then we know that two things must be true. The first thing is that f of x must be continuous. You saw it in our first example yesterday, is that f of x, if it wasn't continuous, then we would have no derivative at that value. The second thing is that the derivative, the limit of the derivative from both sides must be matching up, okay? So we're going to use that in some of these example problems that we've got coming up here. And we're going to start here with this problem, okay? So is g of x continuous at x equals to 3? And we're going to do our complete analysis, as you always should. All right, so here's our function. We've got a nice piecewise function. And so we're going to do all three of those parts. So the first thing is, what is g of 3? Is it even defined, okay? And so we're going to be using this one right here. And so I'm going to substitute that in square root of 3 plus 1, and I'm going to get 2 from that, okay? So now we're going to see if the limits from both sides match up. So let's do that. So the limit as x approaches 3 from the left of g of x. Well, we just did that. We know that's equal to 2. And so now let's do the limit as x approaches 3 from the right of g of x. Okay, so then that's going to say 5 minus 3, which is going to be equal to 2. So that means for us that the limit of g of x as x approaches 3 is 2. Coming down to our final part is that, all right, so the limit of g of x as x approaches 3 equals g of 3, and they both equal 2. So therefore, g of x is continuous at x equals 3. From everything that we've just done, it's all just to say that it's continuous, okay? So now we're going to take that into, is it differentiable, okay? So now we're going to take our graphical evidence from our previous video, and we're going to see if we can tie that in, okay? So the first thing is, all right, we need to show that it's continuous. So g of x is continuous at x equals 3. We already showed all that analysis up above, okay? So now we need to find the limit of the derivatives, okay? So let's find g prime of x real quick. All right, so g prime of x, and that's going to be, in that first one, we've got the square root. So I'm just going to rewrite it right here above. What was it? It was going to be x plus 1 to the 1/2. All right, so I'm going to bring the 1/2 down, x plus 1 to the negative 1/2, and then times 1. Okay, so that's going to be from 0 less than or equal to x less than or equal to 3. And then our second function was 5 minus x, so that derivative is just negative 1, and that's going to be from 3 until 5. All right, so now what I'm going to do is find each limit. So the limit as x approaches 3 from the left of g prime of x. All right, so I'm going to use my first function, and that's going to be 1 over 2 square root of 3 plus 1, just if I rewrite that real quick. And that is going to be 1 over 2 times 2, so 1 over 4. And then the limit of g prime of x as x approaches 3 from the right side, I'm going to use my second one, and that's just a constant. That's always going to be negative 1, okay? So they don't match up. So what we're going to say is that g of x, so therefore g of x is not differentiable at x equals 3 because the limit of g prime of x as x approaches 3 from the left does not equal the limit of g prime of x as x approaches 3 from the right. Or you could say something like the limit of g prime of x as x approaches 3 does not exist or is undefined, something like that. So that therefore is not differentiable at x equals to 3. All right, so it's a lot to keep memorized, but you do need to like start making flashcards and start memorizing the rules for continuity, the rules for differentiability, for your trig derivatives, natural log and log functions. Like, you need to have those things memorized. You cannot get through calculus without it. So we've got a couple more problems where you're going to be using additional information, tying together a lot of information to figure out additional values, okay? So we know that we want this function above me to be both continuous and differentiable, okay? So the first thing is for continuity. For continuous things, we want a couple things to be true, okay? We want the limit of f of x as x approaches 3 from the left to equal the limit of f of x as x approaches 3 from the right. That's going to be a huge part of it. If that happens, everything else kind of falls into place, okay? So what are we going to do? Well, I'm just going to write these down from the given pieces of information from h of x. And so I'm going to write down the limit. Well, I don't need the limit anymore. I'm going to write down k square root of 3 plus 1 needs to equal m times 3 plus 2. Okay, so let me just clean that up. So I get 2k equals 3m plus 2. All right. And so there's really not much more I can do with that there. So I'm just going to move over, and because I also want this to be differentiable, right? So I'm going to move over here, and I'm going to start to work with some stuff in this area. Because if it's differentiable, well, then we know, very similar to continuity, is that the limit of h prime of x, and now that I'm looking at it, all of these things shouldn't have been f's. They should have been h's. So let me go fix that. H and h limit. And so h prime of x as x approaches 3 from the left needs to equal the limit of h prime of x as x approaches 3 from the right. All right, so let's take this derivative real quick. So I'm going to rewrite this as I normally do, just because I freak out if I don't rewrite it. Okay. And so, all right, so I'm going to take this derivative. I'm going to write down h prime of x is equal to, and let's figure this out. So bring the 1/2 down, 1/2 k, because that's a constant multiple. And then we get x plus 1 to the negative 1/2 times 1, okay? And I'm not going to write down the domain here just to save some time. And then I'm going to get m, yeah, just m. Oh, okay. That's pretty simple. So now that I can take that, I can use that to find the limit of h prime as x approaches 3 from the left and from the right. So I'm going to write that here, and I'm going to say, all right, so I get 1/2 k. Actually, let me rewrite that a little bit. What I'll do is I'm going to say, okay, so k is going to stay in the numerator. So I'll get k over 2 square root of x plus 1, but it's not really square root of x plus 1. It's just going to be square root of 3 plus 1, because I'm finding the limit as x approaches 3, equals m, because it's just a constant. All right, so I get k over 2 times 2 is 4, so k over 4 equals m, and I'll just say k equals 4m. All right, so I've done a lot of work here, and what I'm going to do is I have this value for k. I know it's 4m, and I'm just going to substitute that into this k over here. So let me move back over to this side here, and what I'm going to do is I'm going to say, okay, so 2 times 4m equals 3m plus 2. And now it's just, I can figure out what these values are. Let me give myself a little bit of extra space. And I'm going to get 8m plus 3m, sorry, 8m equals 3m plus 2. And then so I get 5m equals 2. So m will get me 2 fifths. And since m is 2 fifths, I can take that value and figure out what k is. So we know that k is 4 over m because we wrote it right there. So we're going to say k equals 4 times m, which we just found is 2 fifths. All right, so k is going to give me 8 over 5. And that can't be simplified. So we have found the values for m and k, 8 fifths and 2 fifths, that are going to make this function continuous and differentiable. And what I would challenge you to do is to put in these functions on their domain into your calculator, no matter what kind of calculator you have. Figure out at those endpoints, at the point where those two functions meet at 3, do they have the same y value? And use the calculate function for the derivative that you learned about in our previous lesson and see if they come out with the same derivative as well, okay? We've got another problem just like this, except now we've got some squares, some things are going to be looking pretty gnarly, and that's totally okay, okay? So we're going to get through it just the exact same way. So we're going to start with continuity. Close enough. And what are we going to say? So we're finding this at x equals 1. We know it needs to be differentiable. And since it's differentiable, we know it has to be continuous, all right? So that's why I start with continuity. So the limit of f of x as x approaches 1 from the left must equal the limit of f of x as x approaches 1 from the right. Okay, so as I write these out, I'm going to write these out from our functions up here for f, and I'm going to say, okay, so 3 a times 1 squared plus 2b times 1 plus 1 equals a 1 to the 4th minus 4b 1 squared minus 3 times 1. All right, so I get, if I'm doing this right, I am going to get 3a plus 2b plus 1 equals a minus 4b minus 3. All right, so from that, I'm just going to kind of solve for like a and b, write them out as constants. So what I see from that, if I bring the a's, I'll get 2a and then plus 6b equals, and I'll move the constant to the other side, kind of like in standard form. So I'll subtract 1, I'll get negative 4. Okay. So 2a plus 6b equals negative 4. Cool. Now we're going to go to the differentiable part. And so since it's differentiable, let's find f prime of x real quick. So f prime of x, I'm going to take those derivatives, no funky square roots or anything, so it's just going to be constant multiples. So the power rule here, I'm going to get 6ax plus 2b, and then I'm going to get 4ax cubed minus 8bx minus 3. All right. And so, and again, it's because we know a and b are all constant. So I'm just using those as constant multiples. All right. And so what I want to do is that the limit of f prime of x as x approaches 1 from the left, and I want to make sure that that is going to equal the limit of f prime of x as x approaches 1 from the right. And again, it just goes back to your definition of differentiability. You want them both to meet up. You want them both to match, okay? So as I'm going through this, I'm going to substitute in those values for x. So I'm going to get 6a times 1 plus 2b. And honestly, the 1 makes it a lot easier. And that's going to equal 4a times 1 cubed minus 8b times 1 minus 3. All right, so let's see what I can simplify here. I get 6a plus 2b equals 4a minus 8b minus 3. Okay, same thing, I'm going to kind of put it in a standard form. So I'm going to get 2a, add 8, so plus 11b equals negative 3. All right. So now again, as I'm looking at those two things right there, I am trying to determine how can I solve for A, how can I solve for B, and what I we could solve for a. Honestly, it might be pretty easy to solve for a here and do substitution, but just to differentiate my methods, not meaning differentiable, different differentiate here, but just to change up my methods, I'm gonna solve for this using elimination. All right, so I'm gonna write this function that I have over there on the right side, and I'm gonna bring it over to the left. I'm just gonna rewrite it here. So 2a plus 11b equals -3. And what I'm gonna do is I'm gonna subtract these two functions. And so what happens? So I get 2a minus 2a, those are gonna cancel out. And then I get 6b minus 11b, so I get -5b. And I get -4 plus 3, so I get -1. So b, -1 divided by -5, I get +1/5. And so I have, now that I'm looking at some of my work, I think I might have made a mistake somewhere. I did make a mistake. So if you've caught this mistake as I'm going through it, it's right up here. And I just checked my notes and I noticed something, that I made a small arithmetic error. So right here, I write down 2b and I add 8b to that, okay? Because I'm bringing that 8b to the left side. And you might be thinking about this. If I had 2b's and I add 8b's to that, I don't get 11. I saw that 3 out of my peripheral vision. I was like, oh, right, 8 plus 3 is 11. But it's 2 plus 8, and that should have been a 10 right there. If you caught it and you were like, oh, Mr. Hernandez, and you can't stop me because this is a video, then great job on you. All right, I was just making sure everyone was paying attention here today. So we're gonna get 10b right there, which means that some of our values right there are gonna change. So 6 minus 10, I'm gonna get -4b. And then -1 divided by -4, I'm going to get +1/4. All right, so now I'm gonna take that b value and I'm gonna substitute it in. And it doesn't matter whether I use the function on the left or this function here. And what I'm gonna do is I'm gonna use the function on the right. So I'm gonna move over here real quick so I have some more space to write in this area kind of. So I'm gonna say, okay, so 2a plus 10b, which is now 1/4 equals -3. So I get 2a plus 10 over 4, which is 5 over 2 equals -3. And I've got a small trick that I do with that. If I got just a constant in my denominator, like divided by 2, I'm just gonna multiply every term times 2. And so I'm gonna get 4a plus 5 equals -6, just like that. So that 2 goes multiplied by the 2a, multiplied by the -3. All right, and it makes it a little bit simpler than just handling fractions the entire time. And so I subtract 5 on both sides, so I get 4a equals -11. And then I divide by 4, so I get a equals -11/4. And from that, I know that b equals 1/4 and a equals -11/4, okay? Do not fear those fractions. As we continue to move forward, you're going to get answers that include fractions, okay? You got to deal with it. You guys are calculus students and you guys are the best of the best on your school, all right? So make sure that you do not fear these problems and do them multiple times. I always talk about the repetition until you feel comfortable with a problem like this, okay? Of course, if you do need any help with any parts of this lesson, please reach out to me. I'm Mr. Hernandez, and this is Mr. Hernandez Teaches.